Hello everyone, welcome to another video. Let's solve the physics question on the board. A, we have when a positively charged conductor is placed near a candle flame. We have a conductor carrying positive charges placed near the flame of a candle. This is the candlestick and this is the flame of the candle. The flame spreads out as shown in the diagram. Explain this observation. The flame contains charged particles known as positive ions and negative ions, and that will be due to heat and combustion process. So when a positively charged conductor is placed near a candle flame, the conductor will attract negatively charged ion, that is the negatively charged particles, and repel the positively charged particles in the flame. So which means that the movement of the ions, that is the movement of the charged particles, will create an electric force that will push the flame outward, making it spread out. So which means that when a positively charged conductor is placed near a candle flame, the flame spreads out because the conductor will produce an electric field that will affect the charged particles in the flame. And that explains question A. All right, so now the answer to the question will be that solution. So for A, when a positively charged conductor is placed near a candle flame, the flame spreads out. The flame spreads out because the positively charged conductor, attracts negative ions, okay, in the flame, and repel positive ions in the flame. The movement of ions, that is charged particles, the movement of charged particles in the flame creates an electric force that pushes the flame outward, making it spread out. So that explains that's question A. Now B, we are given a proton moving with speed of 5.0 times 10 raised to the power of 5 meters per second. So we have speed of proton, okay, to be 5.0 times 10 raised to the power of 5 meters per second. Centers a magnetic field of 2.0 Tesla. So we have a magnetic field of 2.0 Tesla, okay, at an angle of 30 degrees. So angle of inclination is 30 degrees. Now calculate the magnitude of the magnetic force. We are given the proton charge to be 1.6 times 10 raised to the power of minus 19 coulomb. So the charge on proton is given to be 1.6 times 10 raised to the power of minus 19 coulomb. So our task is to calculate the magnetic force, okay? To calculate the magnetic force, Now, to calculate the magnetic force, we're going to make use of the formula. Magnetic force will be equals to electronic charge multiplied by the speed of proton multiplied by magnetic field intensity, okay? Then sine of the angle of inclination. So in this case, the magnetic force will be equals to 1.6 times 10 raised to the power of minus 19 multiplied by 5 times 10 raised to the power of 5, then multiplied by 2, then sine 30 degrees. Okay, 2 multiplied by 5, that's 10. 10 multiplied by 1.6, that will be 16. We have 16 times 10 raised to the power of negative 19 multiplied by 10 raised to the power of 5, then multiplied by 0.5. So 0.5 times 16, that will be half of 16, and that's 8. So that this will be 8 times 10 raised to the power of minus 19 plus 5. Then we have 8 times 10 raised to the power of negative 14 Newton. This is the magnetic force, okay, on the proton moving with speed of 5.0 times 10 raised to the power of 5 meters per second. I'll see you in the next video. Bye-bye.